Hi, this is Arash and welcome to the Epoxy channel. In this channel, we're going to talk about the epoxy resins from the theoretical aspects to the most practical ones. So if this is the first video that you're watching, or if you're interested in epoxy resins, please like and subscribe to our channel for more videos. Today, I'm going to present chloride content of epoxy resins.
Chloride content is one of the key parameters of epoxy resins, and based on the standard it has to be reported because it has effects on the use of or applications of the resin. The epichlorohydrin is used in the synthesis of the bisphenol A epichlorohydrin systems. It attaches the epoxy group to the ends of the molecule and the chlorine is removed, often as sodium chloride. So despite the name bisphenol A epichlorohydrin, it doesn't contain any chlorine except for any chlorine atoms presented as impurities. So in principle, your epoxy resin doesn't contain any chlorine, neither before nor after hardening. But all epoxy resin based on epichlorohydrin can contain chlorine by way of impurity, either as chloride or bound to carbon. Here you can see the structure of the chlorine presented in epoxy resin. It could be in chlorine or free form, known as chloride, in this form, known as 1,2-chlorohydrin, and so on. As impurities, chlorine critically affect the properties of the resultant coating or the application process, and it should be determined accurately, often based on different standards, which I have provided for your reference here. Let's look at different types of chlorine impurities based on ISO standard. This chlorine impurity could be reported as inorganic chlorine, readily saponified chlorine, and total chlorine. Inorganic chlorine, for measuring the inorganic chlorine, the resin is dissolved in a suitable solvent such as acetone, methyl ethyl ketone, or a tetrahydrofuran, and titrated potentiometrically against silver nitrate to determine the chlorine content. In readily saponifiable chlorine, the epoxy resins are made to react with butoxyethanol in NaOH solution with release of bound chlorine. This solution is acidified with glacial acetic acid and titrated potentiometrically against silver nitrate solution to determine the chlorine content. The inorganic chlorine content must be subtracted from the results before reporting. Finally, the total chlorine. The resin is dissolved in diethyl glycol monobutyl ether and heated under reflux in alcoholic NaOH solution so that the resin is completely saponified. The resultant solution is titrated potentiometrically against silver nitrate solution to determine the chlorine content. Now, let's look at the chloride impacts and its relevance in this resins. The market of epoxy resin is expanding to adhesives and sealant, which are used in circuit boards and electronic devices such as personal computers and cell phones. Chloride impurities included in epoxy resin corrode wirings of circuit boards and damage them, so a resin with high chlorine content cannot be used for those purposes. It also generates poisonous gases in the case of circuit board burns. The other impact of the chlorine in the epoxy resin system lies in their pot life. When an epoxy resin contains chlorine, its pot time reduces drastically. So here you can see in a schematic where, for example, a resin with 0.2% of chloride would have almost 10% reduction in its pot life. So it must be measured and reported accurately.
Thanks for your attention. I hope you enjoyed the video. Please share your thoughts, questions, and comments, and I will come back to you soon. See you.